Hello students, welcome to St. Thomas School, Surat. Standard 8, Subject Mathematics. I am Sindhu, your maths teacher. Today we are going to study Chapter 1, Rational Numbers. Before going to study rational numbers, we are going to discuss about types of numbers. First one, natural numbers. Counting numbers are called natural numbers. It is denoted by n. N is equal to set for 1, 2, 3, 4, etc. Second, whole numbers. When we add the number 0 to the collection of natural numbers and obtain the whole number, which is denoted by W. So W is equal to set for 0, 1, 2, 3, 4, etc. Third one, integers. The collection of positive numbers, zeros and negative numbers are called integers. It is denoted by Z or I. Z is equal to set for -3, -2, -1, 0, 1, 2, 3, etc. Rational numbers. A number which can be written in the form P by Q, where P and Q are integers and Q not is equal to 0. For example, -2 by 6, 6 by 7 are rational numbers because the denominators are not 0 and they are written in the form P by Q. Another example, that is 0, -2, 4. Can we say they are rational numbers? Yes, they are also rational numbers because they can be written in the form 0 by 1, -2 by 1 and 4 by 1. Properties of a rational number. Closure property. Rational numbers are closed under the operation of addition, subtraction and multiplication, but it is not closed under division. For example, addition 3 by 8 plus -5 by 7. They are unlike fractions, so first we have to convert it into like fraction. So find the LCM, that is 8 7s are 56 because 7 is a prime number, so we can multiply both the numbers. So 3 multiplied by 7 plus -5 multiplied by 8 divided by 56. 3 7s are 21 plus -5 into 8, that is -40, plus into minus, that is minus. So 21 minus 40. So one is positive number and one is negative number, we have to subtract. 40 minus 21, that is 90. And this is the greater number, that is 40, the sign is minus. So answer is minus 19 by 56. So it is a rational number. When we add two rational numbers, the answer is a rational number. We can say that rational numbers are closed under the operation of addition. Next example for subtraction, -5 by 7 minus 2 by 3. They are unlike fractions. So first we have to convert to like fraction. The LCM of 7 and 3 is equal to 21 because 7 and 3 are prime numbers. So multiply 7 and 3, that is 21. So -5 multiplied by 3 minus 2 multiplied by 7 divided by 21. 5 3s are 50, the minus sign, so -50 minus 2 7s are 14. Both are negative numbers, so we can add 15 plus 14, that is 29, and put the minus sign, -29. So -29 by 21 is a rational number. So when we subtract two rational numbers, the answer is again a rational number. That is, closure property is closed under the operation of subtraction. Next example for multiplication, -2 by 3 multiplied by 4 by 5. So -2 multiplied by 4, that is -8. 3 5s are 15. So when we multiply two rational numbers, the answer is again rational number. So we can say that Closure property is closed under the operation of multiplication. Next is division. Already we said closure property is not closed under division. For any rational number a by 0 is not defined. For example, 5 by 0, it is not defined. So, rational numbers are not closed under division. Second, commutative property. The operation addition and multiplication are commutative for rational numbers. For example, minus 2 by 3 plus 5 by 7. They are unlike fractions because we have to convert to like fraction. To convert like fraction, we have to find LCM. So LCM is equal to 3 multiplied by 7 because 3 and 7 are prime numbers. So multiply 3 and 7 to get the LCM. 3 sevens are 21. Minus 2 multiplied by 7 plus 5 multiplied by 3 divided by 21. 7 multiplied by minus 2, that is minus 14, plus 5 3s are 50 divided by 21. One positive number and one negative number. So we have to subtract and add positive numbers. So 15 minus 14, that is 1, and 15 is the greater number, sign is positive, so 1 by 21 is the. Now interchange the numbers and add 5 by 7 plus minus 2 by 3. Again 7 and 3, LCM is 21. So 5 multiplied by 3 plus minus 2 multiplied by 7 divided by 25. 5 3s are 15. 7 multiplied by minus 2, that is minus 14 divided by 21. Again one positive number, one negative number, we have to subtract and add greater number sign. So 15 minus 14, that is 1, and 15 is the greater number, the sign is positive and 21. In both the case, answer is 1 by 21. So, minus 2 by 3 plus 5 by 7 is equal to 5 by 7 plus minus 2 by 3. That is, if A and B are two rational numbers, then A plus B is equal to B plus C. This property is known as commutative property. Example 2 for multiplication. Minus 7 by 3 multiplied by 6 by 5 is equal to 6 multiplied by minus 7, answer is minus 42, and 5 is the 50. Interchange the numbers and multiply. So 6 by 5 multiplied by minus 7 by 3 is equal to, again 6 multiplied by minus 7, answer is minus 42 by 15. In both the case, answers are same. So minus 7 by 3 multiplied by 6 by 5 is equal to 6 by 5 multiplied by minus 7. That is, if A and B are two rational numbers, then A multiplied by B is equal to B multiplied by. The operations subtraction and division are not commutative for rational numbers. For example, 2 by 3 minus 5 by 4. They are unlike fractions, so we have to convert to like fraction. To convert like fraction, we have to find LCM. Here 3 and 4 are prime numbers, so multiply both the numbers. So 3 multiplied by 4 is equal to 4. 2 multiplied by 4 minus 5 multiplied by 3 divided by 6. 2 4s are 8 minus 5 3s are 15 divided by 4. Again one positive number and one negative number. So we have to subtract and add greater number. So 15 minus 8, that is 7, and 15 is a greater number, so sign is minus, so minus 7 by 6. Interchange the numbers, 5 by 4 minus 2 by 3. Again LCM is 12, so 5 multiplied by 3 minus 2 multiplied by 4 divided by 2. 5 3s are 15, 2 4s are 8, 15 minus 8, that is 7 by 4. So in both the case, answers are not same. So 2 by 3 minus 5 by 4 not equal to 5 by 4 minus 2 by 2. That is, if A and B are two rational numbers, then A minus B not equal to B minus A. Example 2. Division. 2 by 3 divided by 5 by 4. You know that when we divide fraction, we have to put multiplication sign and take the reciprocal of the given number. So here, reciprocal of 5 by 4 is 4 by 5. So that is 2 by 3 multiplied by 4 by 5. 2 4s are 8, 5 3s are 15. So that is 8 by 15. In the change the number 5 by 4 divided by 2 by 3 is equal to, write the first fraction as it is, 5 by 4 multiplied by 3 by 4. Reciprocal of 2 by 3 is 3 by 4. 5 3s are 15, 4 2s are 8. So both the answers are not same. So 2 by 3 divided by 5 by 4 not equal to 5 by 4 divided by 2 by 3. That is, if A and B are two rational numbers, then A divided by B not equal to B divided by C. Third one, associative property. The operation addition and multiplication is associative. If A, B and C are three rational numbers, then bracket A plus B plus C is equal to A plus bracket B plus C, and bracket A multiplied by B multiplied by C is equal to A multiplied by bracket B multiplied by C. The operations subtraction and division are not associative. We can take some examples just like what we have done in commutative property. Next point is additive identity. The rational number 0 is called the additive identity for rational numbers because when you add 0 to a rational number, the sum is again that rational number. That is, a plus 0 is equal to 0 plus a is equal to a, where a is the rational number. For example, if we take 5, so 5 plus 0 is equal to 0 plus 5, again is equal to 5. And 5 is a rational number. Multiplicative identity. The rational number 1 is the multiplicative identity for rational numbers because when you multiply any rational number with 1, you will get the same rational number as the 1. In general, a multiplied by 1 is equal to 1 multiplied by a is equal to a for any rational number a. For example, 5 multiplied by 1 is equal to 1 multiplied by 5 is equal to 5. So 5 is a rational. Additive inverse. The additive inverse of the rational number a by b is minus a by b. For example, the additive inverse of 4 by 5 is minus 4 by 5. Multiplicative inverse. The multiplicative inverse of reciprocal of the rational number a by b is c by d. There is a condition for that. If a by b multiplied by c by d is equal to 1. For example, multiplicative inverse of 4 by 5 is 5 by 4 because when we multiply 4 by 5 and 5 by 4, here 5 and 5 cancel, 4 and 4 cancel, so what we get? 1. So the product is 1, so we can say that 5 by 4 is the multiplicative inverse of 4 by 5 or 4 by 5 is the multiplicative inverse of 5 by 4. The number 0 has no reciprocal and the numbers 1 and minus 1 are their own reciprocal. That means the reciprocal of 1 is 1 and the reciprocal of minus 1 is minus 1. The last property is distributive of multiplication over addition and subtraction. For all rational numbers a, b and c, a multiplied by b plus c is equal to a multiplied by b plus a multiplied by c, and a multiplied by b minus c is equal to a multiplied by b minus a multiplied by c. For example, 2 multiplied by x plus 4, this in bracket, is equal to, remove the brackets one by one, 2 multiplied by x plus 2 multiplied by 4. This 2 multiplied by x, that is 2x, 2 multiplied by 4 is 8. And in the case of subtraction, 2 multiplied by x minus 4, that is in bracket, is equal to, again remove the bracket, so 2 multiplied by x minus 2 multiplied by 4. 2 multiplied by x is 2x minus 2 4s are 8. The chapter will continue in the next video. Thank you.